So this time we will edit the solution, okay? So click on solution and just click on edit. Yeah. So, okay, this class I think will be short because in this class we will only be discussing the post-processing part. So let's see what we can do. So actually, there are two places where you can do post-processing. Firstly, this is Fluent Solver. Here also you can do processing. Okay, let me make it this default view. Yeah. So here also you can do your post-processing, as well as in results section also you can do your post-processing. So firstly, we will do the post-processing here, and then we will move on to the results. So, okay. Firstly, let's check out some contours. Okay, so last time I hope that you were able to do all the calculations, right? The results were converged. Hello.
Yes, sir.
Yeah, so just read this console that there must be some number and some dat file must have been opened by default. Okay, so after that, so we will make our contours. So firstly, in the results section in the outline view, open the graphics window and double click on the contours. Okay, so firstly, yeah, by default, this will be a filled contour and this will be a smooth contour in this version of ANSYS. It may be different. If it is different, you can just change it accordingly. And okay, let's see the velocity contour. So just this is a contour of pressure by default, so change it to velocity. And yeah, just let it be on velocity magnitude only. And yes, this is very important. You won't choose any surface here. Okay. Suppose in some cases it may be by default this is selected or anything else is selected. So just click on this cross button here, and there should be no surface selection here. Okay. And then just click on save and display. And here, yes, you will be able to see this velocity contour. So please confirm if you are able to achieve the same result.
Yes, sir.
Okay.
Yes, sir. Done.
Okay. So next we will look at, lastly, in last class we discussed that this is only a half pipe, right? As you can see that this was the axis and this is the upper half of the pipe. So now we will make the full pipe from these results. So to do that, go to the view here in the upper part here, like I'm showing you. This is, I think, called the ribbon bar. So in the view sections, in the view, go to views, okay, and click on this axis, mirror planes, axis, and click on apply. And then you will find that the pipe is fully made in the results. So is it done?
Yes, sir.
Okay. So this is what axisymmetric analysis is for. So you see that the solver just solved the results in the upper half and just copied and pasted the results in the lower half. And that's how this whole solution is done in the axisymmetric analysis. So, okay, nextly, let's make some other contours. Okay, no, a contour only, this is very helpful. If you want, you can make other contours as well, like pressure contour. Here you can see save and display, and this will be a pressure contour. So, okay, firstly, come to this velocity contour only. We will explore some other options as well. So, yeah. So here you can see that there are some various options. So let's check out this banded one first. You can see that this color variation is continuous. This changing from blue to red, this is a continuous in nature. So what I mean by that is, let's check out the banded contours first. So if you click on banded, yes, here you will be able to see these bands of the colors, right? So this is just the difference. It just depends on the visuality, what all visual results that you want. So you will find that in most of the research papers, results are generally posted in this manner, this banded contours manner. And secondly, the important thing is this filled contour. This is called a filled contour. If you will untick this and then save and display it, yeah, only contour lines will be visible. So sometimes even results can be presented even in this format as well. Okay, so this is just to show you the variation. of the velocity. Like at each line, the velocity will be different. Okay. So okay, let's check out some other things. Yeah. So go to the color map option. Okay. So these you can see that there are only a very few number of contour lines visible. So to increase this number of lines, you can just go to the color map options and this color map size. If you will increase the size, this number of lines will increase, and you can increase it up to 100. So this is by default 20. So if you will increase to 50 and apply it, and you can see that the number of lines will increase this density. So, okay, what this does as well, yeah, you can see that the legend, even this legend has become somewhat, clunky. So, okay, so firstly, let's do one more thing. This console window, we will maximize it. So to do that, actually, you won't be able to directly maximize it. You see this console right here written in your screens as well, right? So just hold this and just drag it to this place, like wherever this whole blue screen will appear. And as this soon as this will appear, just release your button. So this console will come here, and similarly do the thing with the task page as well. Just click on it and just click in here. Now we can switch in between these three windows from this bottom here. Okay. So let's come to the graphics. Yeah. So here you can see that this legend has also become very clunky. So we can do that by going again to the color map options and by skipping it. So you can see that with 20, the skip was 2. So with 50, if you just increase it to 5, you will find that, yeah, this legend has improved, right? So again, to get the maximum accuracy in these contours, you can make it 100 and skip to 10, okay? And just apply it. So yeah, this is like the maximum color band that can be formed in this Fluent. So in the, okay, we will discuss it later. So nextly, we will look at this precision. So precision is just for this manipulating the whatever is visible in the legend bar. So you can see that precision, it is right now it is up to 2 digits after the decimal. So you can increase that as well. So normally it will be up to 2 only. You can increase it up to 9. Like suppose we will see it at 4 and just apply it, and you will see that after the decimal, the digits are now 4. So we can just leave it at 2. And other thing that we can do is we can set the color map alignment, like this legend alignment. Right now it is on left. We can change it on bottom and apply it. So this contour, this legend will now appear like this. So you can do various things. Yeah, you are free to explore it on your own. Okay. So this is just the contours that we are discussing. Next, okay, the by default, the best visually contour appears in this filled option and smooth. So by these options, the visual nature of the contour is best. And yes, again, if this is selection is happening by default, then no problem. Otherwise, you will just unselect everything, okay, from this crossbar and just save and display it. Remember, in 3D, it won't work. This is only done in 2D analysis. In 3D, you have to make a plane again. And yeah, I will leave it up to you to find it out on your own. So yeah, this is just for 2D. Okay, so nextly we will see the vectors. Just below the contours, there must be option for vectors. So yeah, by default, it will be set on velocity only, and actually that's what we need most in the most cases. So we can just display it. And yes, here you can see that yeah, the density of the arrows are very too much. If you will zoom it in, you will see that yes, this is one arrow, and on the top of it, this is another arrow. So yeah, to just improve it, you can yeah skip it. You can increase the number in the skip. So if you skip 10, save and display. So some arrows will disappear. Okay, and you can change the size as well, size of these arrows. Like change the, I think 3D arrowhead is good. Yeah, but we will keep it at 3D arrow only. Yeah, I think in the vector options, no. Maybe by scale, I think. Yeah. So if you reduce the scale, the size of the arrows will also become shorter. So okay, these are just a few things that you should know. This is like the basics of the post processing. And okay, secondly, we will look at this some important thing now. Okay, so tell me, you have studied about the boundary layer theory. Have you, Krish and Dhruv? Sorry, Krish and Bhargav?
Yes, sir.
Okay, okay. So you must know that in the boundary layer, in this laminar type of flow, the shape of this velocity at any point of time is like this, right? We will see that right now. So what we need to do for that is we need to draw a line, okay, a vertical line, let's say at the center of the pipe. We will draw it. So you remember that when we started creating the geometry, we started from the origin. Okay, so now it will help us because you know that we started from the origin and the length of the pipe was 100 mm and this diameter was 10 mm, the radius was 10 mm. Okay, so to create a line, go to domain first. Okay, if it is in view, go to domain, and in the surface here you can click create, and this time we will create a line. Okay, line and rate. So here you need to put these x and y coordinates to create a line. So okay, so you know, like 2 points are needed to create a line. So firstly, if I want the line at the center of it, the x coordinate of that point should be what? Tell me. Hello, are you listening?
Yes, sir.
Okay, so tell
Yes,
me
sir.
what should be the x coordinate of the center of the pipe? And you know that we started from the origin, so this is 0 and 0, and the length of the pipe is 100 mm. So the center, the x coordinate should be what?
50 mm.
Yes, 50 mm, and of both points the x coordinate would remain same. So 50 mm, yeah, so make sure we convert it in meters. So 50 mm would be 0.05. Okay, so similarly x1 should also be 0.05. Okay, now tell me the y coordinates. So there are 2 points, this bottom point and the upper point. So tell me the y coordinate of the first, the middle point.
Zero.
Yes, it should be 0. And what should be of the upper point?
And
Yes, 10 mm. So again, we'll put it as 0, 1 because in meters. So okay, so these are the coordinates of 2 points that we need to create a line. So after you put the coordinates, just click on this create button and just leave it. Okay, it will be shown again, but it will be a different line. So to view this line, if this line is correct or not, we will go on to display. Okay, but before that, we will create a new window on this graphics view. So to do that, you see where is the heading of this graphics, wherever it is this return, this contours of velocity magnitude. So you right click on this and create, just select new window. Okay. So by this new window in the graphics view will appear. So in this window, let's go to display, and you can choose to display various things that whatever you want. So in here, you can see that there is a line too that we just created. So just click on this line and display it. Okay, so here you will be able to see the various boundaries that we made, and this is the center line that we made. Okay, so tell me, are you doing this as I'm doing it right now?
yes, sir.
Okay,
Showing
okay.
line.
Yeah, okay, okay. So at this line, we will generate a chart of velocity to see the variation of the velocity on this line. Okay. So to do that, you see this below the graphics option. There is a plot option. So expand it and go to XY plot. Okay. So double click on it, and yes, here you will be able to plot various functions. So firstly, again, you change the variable that you want to plot, velocity, and the line on which you want to plot. So this is line 3. And okay, now let's see, plot it. And at this window only it will be plotted. And here you see that it is appearing like this. This is because this direction of the plot that it is plotting. So you see that it is a vertical line. So plot direction should also be in y Cartesian. So to do that, we will just change y to 1 and x to 0. Okay. And now if we'll again plot it, yeah, you can see this. So tell me, can you see the same thing?
Yes, sir.
Okay.
Yes.
Okay. Now tell me one more thing. If you have remembered, what's the inlet velocity that we put in this analysis?
0.4 times 0.5. मतलब 5 into 10⁴ meter per second.
Yes. So 0.30 and 5 meters per second, right? So but still, if you will check out, you can see that the maximum velocity is 0.001 around, and which is just a double of 0.0005 meters that we put. So this is also the thing that you must have studied in the boundary layer theory, that at the center the V is maximum and V max is equal to twice is around twice of the average velocity. Okay, so this is the same results that we are seeing. And if you will check out, yeah, this is at the center of the y-axis. And if you will check out at the very end, this is the point which coincides with the pipe wall. Okay, so at wall the velocity is 0, and if you take the average of it, you will get the 0.0005 meters per second only. Okay, I'll tell you how to check the average for later. Uh, Firstly, let's try to edit this plot. Okay, here you can see that there's just points and every only points only. We need to correct it with some line, okay, to make it presentable. So to do that, go to this curves option. Okay, in the curves option, yeah, you can change the line style and symbol here. So pattern, you can do this one. By default, it's on none. Yeah, because that's why no line is appearing. So you can change it to this dotted line, and symbol you can make none. Okay. If you will make like by default symbol and apply it and save plot it, here you will see that this line is appeared, but still those points are also appearing. So if you want the data in this format, you can do that as well. But otherwise, what we want is no points are needed on the graph. Okay. So to do that, we can just eliminate the symbol in this dialog box by doing selecting it to none. Okay. And apply it and save and plot it. And here you can see that you got a clear line. Okay. So again, there are too many options. You are free to explore it on your own. But I will tell you about exporting as well in this class only, but this at some later time. So, okay, next thing what you want is, yeah, the average that I was talking about. Okay, firstly, we will check this scene as well. So you see this contours. So at one time, we can either plot contour or vectors. Suppose we need two things at once. Okay. So like on this contour, say I want to plot mesh as well. I want to show the mesh as well, whatever like mesh I made. So to do that, firstly, yeah, you need to create the mesh. It won't be displayed by default. So go to this mesh option above the contour. Okay, and just display just these. Okay, whatever. Okay, now let me unselect all of these first, and we'll select firstly only the boundaries, that is inlet, outlet, and pipe wall. Okay, and if will I just display it, yeah, the boundaries have appeared, but I want to create the mesh as well. So mesh is displayed by this interior surface body. Okay, so just click on this interior surface body, save and display it. So you will find that even mesh can be displayed. Okay, so after doing that, just save and display and close it. And if you expand this mesh option, now there is mesh one also. So yeah, so now what we want is we want to show this mesh and velocity contour at one time only. So that's when this scene option can be employed. This is also a very useful tool for visual representation of our results. So yeah, you can see that whatever objects that we have made right now, it will appear here. Okay, so we can like select and unselect from here only. So this mesh one that we created just right now, and this contour one, this is the velocity contour that we made earlier. So just click on it, and it will save and display it. Uh, okay, save and display. Okay, click on this save and display, and here you can see that this, yeah, contour and mesh is appearing on the same time. Okay, and here, yes, of course, you can manipulate the transparencies as well. So this like mesh, if you want to make it somewhat less visible, like you want to set it in the background or something, so you can increase the transparency as well here, either from the bar or from this arrow. So let's set it to 50 first. Okay, and if you will save and display it, yeah, here you will see that it is, yeah, this is much more presentable than before. So that's how you can manipulate certain things. Okay. Okay. Next, lastly, let's check out the average, how to calculate the average. Okay, I think the meeting is about to end, so I will, okay, I think we can see the average first. So to do that, yeah, go to these reports. Okay, in the result section only, there must be an option for reports. Okay, are you still following me till here?
Yes, sir. Yes.
Okay, that's good. So in the report section, you can go to the surface integrals. Okay, so just double click on it, and yes. So on the line that we made, whatever the line that we made, it is called line 3. So you'll just select that surface, and we want the area weighted average. Okay. Again, as soon as you click on the area weighted average, you will be able to manipulate the field variables. Select the field variables. So just select the velocity and compute it. Okay, here you can see as well that the average velocity is appearing here also. And I think, yeah, in the console window also it will be appearing, and with higher level of precision.